So good morning students, welcome to my channel Common Sense Explore. Today you can see my topic, that is linear algebra matrix. It is also important for class 12 as well as for engineering mathematics. So let's start from the chapter matrix. Okay, so first of all, what is matrix? A matrix is nothing but row column arrangement of the given data. Okay, so first of all, suppose a matrix A can be written as like this: A I comma I J, like this. What is this I and J? I is the position. Okay, you can say I and J is the position. I denotes the position towards the row wise and J is in column wise. Okay, so now I am writing here in this way: A equals to, suppose instead of I am writing like this: A11, A12, A13, A21, A22 and A23, 31, A32, A33. Okay, so this is the matrix formation. You have to write with the third bracket or first bracket. Okay, so now see, A I J, I means it is here 1 1, I comma J means I is also 1, J is also 1. So first of all, you need to know how many rows are there, how many columns are there. Row means horizontal line. Here you can draw a horizontal line. How many horizontal arrangement is there? There are 3 horizontal arrangement. So this is called row 1, row 2 and row 3. There are 3 horizontal arrangement. Now there are 3 vertical arrangement also, as well as vertical arrangement is known as column. Okay, so this is column 1, C2 and C3, column 1, column 2, column 3, row 1, row 2, row 3. So how many rows are there? So row can be denoted as M. Please remember, M is denoted as row, means number of rows can be denoted as M, and N is number of column. Okay, so M and M means row, N means column. So how many rows are there in this matrix? So 1 2 3, 3 rows are there, and how many columns? 3 columns are there. So always representation is like this: M cross N, or you can say M by N. So here M is 3 as well as N is also 3. So this matrix is nothing but 3 cross 3 matrix. Okay, so this matrix is nothing but 3 cross 3 matrix. So in this way you have to represent. Suppose 2 cross 3 matrix, I want to represent 2 cross 3 matrix. 2 cross 3 means M equals to 2 and N equals to 3. Okay, so M equals to 2 means number of rows must be 2. Number of rows means horizontal line. So I am writing any arbitrary value 1 5 and 2 9. So this matrix 1 5 2 9 and 3 7. Suppose this matrix. Okay, so how many rows are there in this matrix? 1 2. There are 2 horizontal line. So that means 2 rows into how many columns are there? 1 2 3 columns. So 2 cross 3 matrix. So it is nothing but 2 cross 3 matrix. So in this way matrix can be represented. Okay, so now you can see here Aij, as I told you, Aij is the representation. Now what is the range of I and J? What is the range of I and J? Please remember, range of I and J. Range of I is from 1 to M, means up to maximum number of rows. M is the number of rows, M is the number of rows, and J is from 1 to N. N is the number of column. So maximum up to M, I value means here what is the M value? Here M is 3. So M is 3 means just you can see here the maximum value is A33. Do you understand? So that means maximum value is 3 here. You can see here also J is in between 1 to N. N means here 3 also. So it is also 3. Just see. So that means maximum value you have to count it is, this is the range between I and J range. Okay. Now you can see I am giving an example. So this is all about the first part of the matrix. Now I am giving an example. Okay. I am giving an example. Suppose Aij equals to 1 by 3, okay, 2i minus j, it is given. So question is form a 2 cross 3 matrix. 2 cross 3 matrix means M equals to 2 and N equals to 3. Okay, so now from this equation, how to form? M equals to 2 means number of row must be 2 and N equals to 3 means number of column must be 3. Now from this equation, now I, what is the maximum value of I? As I told you, maximum value of I is from 1 to M. Here M is 2. So that means, can I write maximum value of I is from 1 to 2? Means you can take I equals to either 1 or 2. You cannot go beyond that. Okay. Now maximum value of J is range is from 1 to N. Okay, so can I write J is nothing but 1 2 n means 3 here, so 1 2 3, so that means J value, maximum J value is 1 2 and 3. So this is the 3 value. Now you can write in this way, 2 cross 3 matrix you have to form. So just A11 means when I equals to 1 and J equals to 1, that is A11. Next A12 when I equals to 1 but J is equals to 2. Okay, now A13, A21, A22, A23. Okay, so how many, this is the matrix formation. Just see, you can see 1 1 means 1 and 1. 1 means number of rows and number of columns. So this is the row number 1 and this is the row number 2 and this is the column number 1, this is the column number 2, this is column 3. So this is row 1 and column 1 coincide here, so that's why 1 1. Okay, now row 1 but column 2 coincide here, so that's why A12. In this way, this is the formation. Now you have to form a matrix in this way. Now Aij, or you can, I am writing here A equals to, this is A actually, so A equals to 1 by 3 when I and J both are 1. I equals to 1 means 2 minus 1. Okay, I and J both are 1 because I am taking 1 1, these two values I am taking. Okay, so the answer is coming 1 by 3. So this is nothing but A11. Okay, next A12 value, 1 2 means A12 value is what, 1 I equals to 1 but J equals to 2. I equals to 1 means 2 into 1 2 but minus, that is 0. 0 is coming, I am doing directly. Okay, just normal calculation. A13 means I equals to 1 but J equals to 3. I equals to 1 means 2 into 1 2 minus 3, that is minus 1, so minus 1 by 3. Okay, so A11 this, A12, A13 done. Now A21 equals to, I equals to 2 but this is equals to 1, so 2 2s are 4 minus 1, 4 minus 1 is 3, so 3 cancel, so it is nothing but 1 is coming. Now A22 means both are 2, I and J both are 2, 2 2s are 4 minus 2, that is 2, so 2 by 3. Okay, now A23 means I equals to 2 but J equals to 3, 2 2s are 4 minus 1, that is 1 by 3. So all the data you can see here, all the data has been calculated, 1 1 1 2, all the data has been calculated. Now you can write the matrix formation is like A11 means 1 by 3. Next A12, that is 0. Next A13 is minus 1 by 3. Okay, A21 is 1, A22 is 2 by 3, and A22 and A23 is 1 by 3. So this is the matrix formation of the first case. Okay, so here in this video you can see the types of matrices. Okay, first of all the column matrix. Column matrix means it has only one column. Please remember it has only one column, but row may be anything. Okay, so any number of row can be exist, but there must be only one column. Suppose I am writing in this way. Okay, I am giving an example, 2 3 1 5. Okay, you can see here this is called column matrix, means it has only one vertical line, but how many horizontal line? 1 2 3 4. So there are 4 horizontal line, means it is 4 cross 1 matrix. 4 cross 1 means 4 is the number of rows. Here number of rows is 4, and you can see the number of column is 1, so that is 4 cross 1 matrix. Okay, this so column matrix, please consider only one column, m cross n. M is the number of row, anything you can write, but 1, it must be 1, means number of column must be 1. In the similar way, in case of row matrix it can be written like this. In case of row matrix it can be 2 3 5 1, it can be written like this. Okay, now you can see here how many rows are there. Here must be only one row, just see here it is one row, but how many columns are there? 1 2 3 4 columns, 4 5 6 column may be anything. Okay, but row must be 1. Okay, so row must be 1 means 1 cross, what can I write here? 1 cross 4, or you can in generalized form 1 cross n is the number of rows. Okay, so it must be, it always 1, but it can be anything. Okay, so this is all about column matrix and row matrix. And the next is Okay, do you understand the column matrix and row matrix? And the next is square matrix. Okay, so square matrix can be written as is a square formation. Okay, number of rows and the condition is number of rows and number of column must be same, m equals to m. Okay, suppose I am giving an example 2 3 1 1 0 5 2 7 1. Okay, you can see here number of rows and number of columns are same. Number of rows, just see, this is the number of rows, there are 3 rows and how many columns? 3 columns. So it is 3 cross 3 matrix. So any kind of this kind of matrix, 1 cross 1 or 2 cross 2, okay, or 3 cross 3, means this kind of matrix are known as square matrix, because if you box it looks like a square, right? That's why it is known as square matrix. So this is square matrix, and the next is diagonal matrix. Okay, I am writing here diagonal matrix. Next one, this is the third one, square, and the fourth one is diagonal matrix. In case of diagonal matrix, it is the condition is it must be a square matrix. It must be a square matrix. Okay, square matrix. What is the condition for square matrix? M must be equals to n, means number of rows and number of columns must be same. Okay, in case of diagonal matrix, only diagonal elements, this is called diagonal element. Can you see here? This is called diagonal element. This is called diagonal. A11, A22 and A13. If I write like this, A11, A12, A13, A21, A22, A23, A31, A32 and A33, you can see here this is called diagonal. This is called diagonal of this total matrix. Okay, so this only diagonal value will exist and the remaining all the values will be 0. Suppose I am giving an example, you can understand 3 0 0 0 5 0 1 0 0 1. You can see here only diagonal values exist. Only diagonals are non-zero, rest all the values are 0. So that is called diagonal matrix. Okay, so this is all about square and diagonal matrix. And the next type of matrix is scalar matrix. You can see next type of matrix is scalar matrix. In case of scalar matrix, all the diagonals are equal, special type of diagonal matrix. So scalar matrix is a special type of diagonal matrix. The fifth is scalar matrix. This is a special type of diagonal matrix where all the elements in the diagonal value are same. Okay, just suppose 3 0 0 0 3 0 and 0 0 3. You can see here all the diagonal values are equal. So this is nothing but there are two conditions. One is it must be square matrix, okay, and it must be diagonal matrix. Okay, and all elements must be same or equal in the diagonal value. All elements in the diagonal value must be equal. This is called scalar matrix. Okay, and the next type of matrix is identity matrix. Next type of matrix is number 6, identity matrix. You can see here identity matrix. Identity means all the diagonal value having one value. All the diagonal is having one value, just like this 1 0 0 0 1 0 0 0 1. You can see here all the diagonal is 1 only. Okay, so it is a 3 cross 3 matrix. Diagonal it is represented as I1, I2 and I3 in this way. Okay, so it is represented as I1, I2, I3. So here it is I3 means 3 cross 3, I2 means 2 cross 2. So all the this is identity matrix, and identity matrix must be a square matrix, and all diagonal must be equal and all must be one value. That is called identity matrix, special type of scalar matrix. Okay, you can say. And the next one is zero matrix, means when all the elements will be 0, when the all elements will be 0. That is called zero matrix. Means I am writing like this, zero matrix. Zero matrix means it is represented as O. All the elements will be 0. That is called zero matrix. Okay, this is called zero matrix. Here you will be able to understand how matrix can be equal. Okay, so please remember, two matrix can be equal. Suppose A is a matrix 2 3 1 4. Equality means two matrix must have the same. First of all, it must be a square matrix, and the second of all the data must be same, like 2 3 1 4. Then only you can say these two are equal, exactly equal, means all the data will be same. Here 2, it is also 2, 3, 3, 1, 1, 4, 4. Okay, so this is called equality of matrices. Suppose two matrices A and B are equal in each other. Suppose I am giving an example, x minus y by x plus y, and it is 2 and 1. This is a matrix, and B is equals to, is nothing but 1, 2, 3, 1. What is the condition to be equal? A and B must be equal. What is the condition? Condition is the first element, here first element must be equal, here second element must be equal, third element must be equal, and fourth must be equal. Here you can see here this and this are equal, and this are equal. But to consider this means first element and first element must be equal, so you have to write in this way, x minus y equals to 1. Okay, and the second one you have to write x plus y equals to 3. Okay, so that means you have to write in this way so that this A matrix will be equal as B matrix. So this is nothing but equality of matrices. Equality of matrices means elements must be same. This element must be equals to this element. Please remember, this element cannot equal with this element, because it is 1 1, this is also 1 1 element. It means particular position must be equal. Okay, so this is all about equality of matrices.